In this video, we're going to be using synthetic division to factor. So you might need to go back to your notes on synthetic division and recap that principle. If you can't factor something easily, you can use synthetic division, especially if you already know what one of the factors is. So let's do this example that's on page 364. This is example number 4. We are going to be asked to factor the function 3x cubed minus 4x squared minus 28x minus 16. And we already know that x plus 2 is a factor. So we know that if x minus k is a factor, then we can factor it. So that means this is in the form of x minus a negative 2. So the thing that we're actually going to be dividing by in this point, setting up our synthetic division with, is negative 2. So to set up the synthetic division, we put negative 2 on the outside. Then we need the coefficients of my polynomial. So in order, that's 3, negative 4, negative 28, and negative 16. So we go ahead and drop down to 3, and we have 3. Multiply it by negative 2, and we get negative 6. Add those together, we get negative 10. Multiply it by negative 2, and we get positive 20. Add those together, and we get negative 8. Multiply that by negative 2, and we get positive 16, and we get 0. This is pretty crucial here. If you don't get 0 here, then that means that this thing was not a factor, which is kind of a problem. But we're mostly going to do problems where I tell you it's a factor, and it is in fact a factor. Okay, these three numbers that you just got, these three things, they're going to correspond with the coefficient of a trinomial if you were able to divide out the x plus 2. So we now have this factored polynomial. We would have the x plus 2, and then we have 3x squared minus 10x minus 8. And notice these values correspond with the coefficients in the trinomial. So we need to keep factoring here. We can just use guess and check. 3 and 1, 1 and 8, or 2 and 4. X plus 2 is like a GCF, so it's just coming along. This will factor into 3x and x. And then the pair that works is going to be 4 and 2, because my outsides here, the 3 and the 4 multiplied together give me negative 12. So I need to make this negative 4, and then I would add 2 there. So this is my factored polynomial. Recall that if this were set equal to 0, we now could use our zero product property in order to find out all of the solutions or all of the roots, because we would know that x plus 2 is going to equal 0, or 3x plus 2 would equal 0, or x minus 4 would equal 0. And we solve each of those equations, and we would get negative 2 as a solution, negative 2/3 as a solution, and positive 4 as a solution. So depending on what you're asked for, sometimes you're just asked to factor, which means you're just left here. And then sometimes you're asked to find the other zeros, or find the roots, or find the solutions, and you'll use your zero product property and go here. Okay, so using this method, I want you to go ahead and try 2 other examples. So go ahead and pause the video. So here are 2 examples that you can try. they tell you to factor completely given that x minus 4 is a factor. So now you can pause the video and try each of those on your own. When you're done, click back on the video for the answer. Okay, here are the work solutions for those two problems. We were told that for both of these, x minus 4 was a factor. Recall that if the binomial given is x minus 4, then that means 4 is actually the solution. So we set up our synthetic division with 4 on the outside, and then all of the coefficients, 1, -6, 5, and 12. We perform the synthetic division to get the new coefficients, which turn our trinomial into a x squared plus 2x minus 3. And we can continue to factor that using guess and check. And so our final factored form is this. In number 6, same thing. If we knew that x minus 4 was a factor, that means that 4 is a solution. So we can set up our synthetic division with our coefficients. We can perform the synthetic division to get our new coefficients of the leftover trinomial. Then we can factor that, and our results are here. Again, if I needed to actually solve for the solutions, I could use my zero product property. For number 5 here, we would say x minus 4 equals 0, x plus 1 equals 0, or x plus 3 equals 0, and then we would solve each of those to get those solutions. The same thing would happen for number 6. Okay, here is another set of examples. I want you to find the zeros of f, given that f of -2 equals 0. So what that means is that if we plugged in -2 for x, we would get 0. So we know that one of the solutions is x minus 2. That means that we know that one of the factors is x plus 2, because if we add this to the other side, we would get x plus 2 equals 0. Therefore, that must be one of the factors. So go ahead and use synthetic division on number 7 and 8 in order to find all of the factors, and then use the zero product property to solve. You can pause the video here to work it out on your own, and then come back when you're ready. Okay, so here are the solutions for those two problems. Recall that we said if we knew that f of -2 equals 0, that means that x equals -2, which we knew as a binomial would be x plus 2. So using our synthetic division, we set it up with -2 as the thing that we're dividing. Use the synthetic division to find these factors. In this case, we got 0 for our linear term. So recall that just gives us x squared minus 9. Hey, that's a dots. So we should be able to factor that quickly into these 3 binomials. And then using the zero product property, we get these 3 solutions. For number 8, same thing. We knew that f of -2 equals 0. So that means that if we plug in -2 for x, we have one of the solutions already, which means that it's a binomial of x plus 2. So we plug in -2, use our synthetic division, we get this trinomial as a result. We can factor that trinomial so that our final factored form looks like this, and then we can use the zero product property to find the 3 solutions. Okay, that's it. Thank you.